The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Okay, it's 0900. We're going to get started. As a reminder, my name's Al Haggerty, and we're going to try to get you oriented here, and we call this the start of your lean journey. And there we go. So by the time we get done, you're going to be able to differentiate between lean and Six Sigma, and I know that one of the attendees today mentioned that that's why they came. We're going to talk about the 5S tool. That's a derivative of the original Japanese lean concepts, and we're going to be able to define the difference between lean and a lean enterprise and stakeholders, and recognize why lean Six Sigma principles are being implemented in aerospace, because it's turned out to be a very, very, very valuable tool. And the fact that today is day one of a journey, it's not something that you just do once and finish it. I was reviewing some of the latest changes, and my wife said, "Gee, you've done this a lot of times. What are you doing?" I said, "We're on version 6." And she said, "What? You changed it 6 times?" And I said, "This is continuous improvement." So we're going to talk about that. So this is a excerpt from The Machine That Changed the World, and sometime, if you get a chance, get that book. And Womack and Jones, ex-MIT professor, he's still alive and he's still kicking, and very, very interesting guy. Developed a whole bunch of data, but it started with the automobile industry. The book, The Machine That Changed the World, is about the automobile industry. And you know, in the late 1800s, cars were brand new and they were assembled by hand. And then Henry Ford revolutionized the production of cars, and the big thing that he came up with was interchangeable parts. Because before that, we handmade parts, and he came up with the concept that if we could make all the parts the same, we could put them in an assembly line, and that started the mass production. Well, along came Toyota after World War II, and Toyota made this huge improvement in how we build cars. Part of it was the concept of statistical process control in terms of how they literally made the parts, but they invented the whole concept of lean. And as you may know, last year, 2007, which is just finished, the Toyota production now exceeded General Motors production for the first time. And from market capitalization, numbers of shares times the value of the stock, they're the largest automobile manufacturer. And as you know, we've gone through a lot of problems with Chrysler, was part of the Daimler-Benz until this recently when Siberius just bought them back. But our automobile industry is in trouble. I just read the other day that General Motors lost $36 billion last year. Part of that was buying back the rights of the displaced workers when they, the severance pay and that kind of stuff, and their health care and so forth. But you can see the difference between, if you look at this, the auto production in the US, these guys, and with the ups and downs, and every time you do one of these, we get these giant layoffs. The nice, smooth Japanese production is as a function of lean. They've continued to improve, and they have a stable workforce. The products continue to be better and better. And I do a lot of jogging, and if you jog along the road and all that, you take a look at the old cars that come down the road. There are Hondas and Toyotas and the Japanese automobiles, the old Chevys and the old Fords. I mean, you see some of them, but they don't last as long. And a good reason is the fact is that these cars, I mean, I tell industry groups, I mean, you ask any college kid about driving a car for 200,000 miles, and they'll say, yeah, I got a Corolla, I got a Camry, I've got a Honda. And there's a reason for it, because the fact is that they have all the bells and whistles, and all the bells and whistles keep working. So we just talked about that in the post-World War II period. General MacArthur wanted to rebuild the industry as part of his, he was the Supreme Allied Commander and, in Japan, and he tried to get the industry going, and he brought Deming from MIT basically to help get a bunch of experts, and he instituted a lot of the statistical process control, and the Japanese took it, took it not for granted. They said they did it with a passion, whereas in the U.S. we didn't. And therefore their cars and their products have worked significantly better. So if you take a look at the early craft concept that was used in the Industrial Revolution and past, just think of a jeweler, a watchmaker. Each one of those little parts was made by hand, filed by hand, put together. And if you wanted to become a jeweler, you became an apprentice, and then you became a journeyman, and then you became a master craftsman. And that was how, in fact, you made the kinds of parts. And if, in fact, you could think of a better way of doing it, the master craftsman would do it, but it was not spread anywhere. I mean, maybe he would teach his apprentice or so forth. But mass production, which we just talked about, Henry Ford, that kind of concept, if we were going to build, years ago, if I was going to build 12 Apaches, we'd put 14 parts in the line, 14 sets of everything. Why 14 if we're going to build 12? Because we're going to scrap them. We don't do that anymore. But that was typical what we would do, and that's pure waste. And the concept was, mass production, reduce the cost, get the efficiency up. And there's no question that this was a lot more productive than the master build it one at a time kind of a thing of a craft person. But here's a big difference. Inspection was a second stage. We would build it and inspect it, build a part and inspect it. Today, in lean thinking, we build the quality process into the production of the part. And we're going to show you later on that inspection does not catch all the errors, In fact, I guess the poker chips that we just saw before was a good demonstration of that. And another significant improvement is that the master, the master carpenter, the master furniture builder, the master bricklayer, any innovation was driven by the guy that was doing the work. Here we had industrial engineers and manufacturing engineers, expert periodic improvements to the process. Under the lean concept, we want every worker to contribute in terms of being able, there's no question that the real experts in the job are the people that do it every day. And trying to glean that information is part of the value of lean thinking. And the biggest thing is really the focus on the customer. See here, the craft, the jeweler was focused on the task of building that watch. The mass production, focused on automobiles. Well, we still want to build automobiles, but the focus was on the product. Here, on the lean thinking, we're trying to deliver value to the customer. And we'll talk more about that later on. But trying to deliver value, want to deliver a Mach 1.6 Super Cruise, high payload, vertical or short takeoff and vertical landing aircraft called an F-35 to the warfighter. That's the value, and we want to be able to do it for $35 million a piece. That is the value to the Air Force, which is the macro customer, the pilot and the mechanic or the detail customers. So big difference in the way we approach the concept. Now we talked about Six Sigma. Six Sigma was developed by Motorola in the 80s. Now, not too many people wear pagers anymore, but when I was a young engineer with that, it was sort of like a status symbol to have a pager. I never got one of the darn things, but pagers were a big deal. And Motorola pioneered that business. And they had 80% market share until, once again, the Japanese and the Koreans came along, and they added a whole bunch of features to those things where they could tell you, when the buzzer went off, they could tell you, who it was and, where they were coming from and what time it was and a whole bunch of features. And they delivered it to the United States cheaper. And all of a sudden, Motorola's business went in the tank. And they tried to analyze what was going on. And they decided that they did a Pareto analysis. We'll teach you about Pareto charts here. but they basically made a ranking of what the issues were, and one of the biggest issues was the fact is that that they had to scrap and rework a bunch of these pagers, and their quality was not as good as the Japanese, and they didn't last as long. The pagers didn't last as long for quality reasons. And so they said, how can we fix this? And basically started to apply the Deming statistical process control to the various design processes, manufacturing processes, and so forth to improve their quality, and they regained their market share, on the pages. So anyway, Motorola in the 80s, in fact, I live in Scottsdale, Arizona now, and the Motorola facility was the one there that did that. But it was improving quality by eliminating defects, and the concept is reduced variation. We're going to talk a lot about that. But on the lean, we're trying to remove the fact that people come to work every day to waste things. It turns out that waste is, the fact is, if this is the perfect way of doing it, and we're doing it now, the difference between what we're doing now and how good it could be is a definition of waste. The Six Sigma is focused on those issues of variation that in fact are causing a problem. We focus on the flow, and you're going to hear the term pull versus push and so forth as we go through this. And we're trying to get rid of the waste to improve the business performance. And it's a lot of small improvements, many of them coming from the workers who do the job every day. And I had to work in Boeing sent me to Japan. I worked in a Japanese factory for a week, and after 2 days of training, had to improve the productivity of a Japanese worker who was making large industrial air conditioners. And that guy was 55 years old, and he was moving so fast, and my job was to improve his productivity by 30%. And I thought to myself, there isn't a worker in the United States that's working as hard, as fast as this guy. And he was doing all these jobs, and I had to figure out that literally it was a repetitive job, and try to improve. And you know, but it was a combination. I did it, but it was a combination of a whole bunch of small things, and that's what we're trying to do. So we're going to learn a lot about variation, the fact that variation causes problem, the waste out of the process. Yes, sir.
Simple broad question. Where does the name Six Sigma come from?
Statistics. Okay. Yeah. I think that, yeah, there's a chart we're going to show you later on, day after tomorrow, that'll actually explain that. But basically, in statistics, sigma in terms of variation. So, you know, 1 sigma is like 30% of the part, 2 sigma is like 66%, 3 sigma, you know, so forth. 6 sigma is like 99.99999% perfect, you know, kind of stuff. Standard deviation in statistics. So, I just came from Boeing helicopters. I was on there for a week last week, helping them on the root end fatigue problem on the Apache attack helicopter advanced composite rotor blade program. And there's a root end problem, and I was there to fix it. But we literally take 6 specimens, has nothing to do with Six Sigma per se, but 6 specimens, and then run out the fatigue test and determine what the high confidence, 99.999% stress level is that we can guarantee the life of the part. And so it's used a lot. We talked about the fact that lean optimizes flow and eliminates waste. Six Sigma stresses quality through the elimination of variation. And certain companies have put all their focus on Six Sigma, and other companies have adopted lean. And over the last 10 or 15 years, we've seen a convergence of companies that use both. And the idea being is that if the basic quality problem is something that we can apply Six Sigma methods, it makes sense. But quite often, in the big picture, the flow is all mixed up, and therefore we're concentrating on limiting the waste in the flow. So there's a lot of companies that, in fact, instead of having a Six Sigma, General Electric, for example, and instead of a pure lean, have in fact merged those two. And so you can see here, Rockwell Collins calls it lean electronics. Textron Six Sigma, Air Force new system is AFSO 21. Boeing now calls it Lean Plus, and that's a change just in the last 2 years. All of these things have merged together. So we're going to talk about the fundamental concepts that underscore both of those. We were talking about, someone mentioned early in the icebreaker and why they were going to come here. They wanted to learn the terms. There's a bunch of terms that we're going to expose you to over the next 3 days. And these terms are the language of Lean. And we'll go through those. And believe it or not, when you take your value test at the end, you'll be a lot more knowledgeable and to be able to explain really what those are. So that's good. And I won't go through those at this point. So we talked about the 5S. There are literally 5 terms and in Japanese that began with the S word, and I can't pronounce them, but they have been translated into English to mean sort, straighten, scrub, standardize, and sustain. And I'm not sure you can see this, but this is a typical factory sorting area, receiving inspection, where the parts come in and they get sorted and inspected. And this is before, and if you can see that right now, there's a place for everything, and everything's in its place. And has a huge impact on the ability to get the job done efficiently. Let me just relate that to your father's toolbox. Your father's toolbox on his workbench, or the plumber that you see, or the mechanic on your car. And, you know, they're in a toolbox. I know that ratchet wrench is in here somewhere. What our job is to do, as the converse of that in terms of sorting and straightening, is to be able to say, I want our mechanic on the line to have all the tools so that he can be like a surgeon. He can be a surgeon. Scalpel, right? And it's all right there, and he knows exactly where it is, and we want to give him the parts and the paper and the tools, okay? The parts that I need right here, the tools that I need to do the job, and instructions so that he knows what to do next if it's in fact he's building multiple products. So we want to be more efficient, and we'll find out that actually straightening out and sorting out is a big improvement. So we're going to do an exercise. Everybody go into your notebook, into your orange notebook, and there's a piece of paper that says 5S exercise, 5S exercise. Looks like this. Now what we're going to do is we're going to do a 5S exercise, and we're going to measure our improvement. We're going to put metrics on this, and we're going to, in fact, put you in shifts of 30 seconds, and what we're good job to do when I tell you to turn the page, I'll time you. You've got 30 seconds, and what we want you to do, you'll see a bunch of numbers. Don't look. A bunch of numbers. And what we want you to do is to find number 1, cross it out, then find number 2, cross it out, number 3, up to 49. You have to do it in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the number, cross it out, find the number, cross it out, and then stop when I tell you to stop. Ready, set, go. Okay. 9.
I didn't get any.
Okay. 3. So round 1, the highest was 11. The average, the average might have been 5 or 6, something like that. So I'm just going to say, okay, that's cool. Okay, so now what we're doing is that we're talking about 5 S's. The second S is we're going to sort these. We're going to sort these, and what we've done is that we've removed some waste out of the system, and we've removed the numbers between 50 and 90, and for our product, we don't need those. So what you're going to do is the same thing. We're going to go in order, find the 1, cross it out, find the 2, cross it out, find the 3, okay? And on your mark, get set, go. Stop. Okay. It's a killer, right? How many?
10.
11.
13.
19.
19. 32.
20.
22. 15. Highest number was 22, and the average is about 11, you know, roughly. Around 2, okay. We've had a productivity enhancement. We've gone from like 11 up to 22. Now we're going to do what we call set in order or straighten. And just think about a factory. We installed a rack system to help locate the numbers. And the numbers go from the bottom to the top and from left to right. Okay, that sort of makes sense, right? Bottom to the top, left to right. And that'll help you. So start over on the left and then go up and then go to the right side. And we'll talk about it. Okay, stand by. On your mark, get set, go. Round 3. $39 was our top. The average is, certainly, like approximately 30. Good. Okay. Now you see that straightening paid off. The third S is what we call scrubbing. It's tough to scrub a piece of paper, but basically cleaning the factory. If you think of an electronics factory, if you had a dirty electronics factory and somebody put a chip down, you'd ruin the chip. That's a simple example, but there's lots of processes. We make I just said I was in a Rudin factory making rotor blades. Composites have to be absolutely clean. So having a factory that's clean helps product. But I can't do something on that one, so we're just going to skip that next one. Okay, the next one is what we call standardize. And we've created a system of ordering the numbers from the lowest to the highest, from the left to the right, and top to bottom. We've put one number in each box, okay, make it easy to get our tools. And we know where our plans are. So this is, we now know where the screwdriver is. We now know where the wrench is and that kind of stuff. Okay, stand by. Ready, set, go. Okay.
49.
Whoa!
49.
You can see on round 4, we basically did it. Everybody, we significantly improved the average. Why don't you review that cue?
Roughly looking at the range and the eyeball mean. We started out real low, kind of consistently bad, right? As we went through sort of intermediate steps, notice the variation actually got bigger, right? Some people took to the improvements quickly, other people didn't. There was actually more variation. In fact, at this last step, we had a weird bimodal distribution. I heard a lot of 30s and a lot of teens, right? Some people got that system, some didn't. But the really good system, with some odd exceptions, both got our performance way up and, very important, got our variation down. There's actually just a couple of outliers here. Almost everybody was on track.
Now, basically, let me translate that to an aircraft example. Years ago, I started in this business like in 1962. They would give a worker a job ticket, and said, the supervisor would get together at 7 o'clock in the morning and say, okay, you're going to build the horizontal stabilizer today. You've done that before. We know how to do it. Here's the job ticket. Clock in on the job. You'd go clock in on the job, and it would tell you that, in fact, you had to go to the blueprint crib, and you'd pull out the blueprints for that, and you'd spread them out. And then it'd tell you that you had a part kit, and you'd go to the parts control, and you'd get that kit. And then it says, oh, I need this tool, and you'd go to the tool crib and get the tools. And now, we started at 7 o'clock, it's about 7:30, and, you've been trying to get your stuff together. Today, we don't do it that way. Today, you get your parts and your instructions. In fact, F-18, Apache, and those kind of things are paperless. So you have a computer that right now and tells you a illustrated way of getting the job done, and it's right in front of you, and the parts are right there. The tools are delivered with the job, or they're at your desk at your workplace all the time. And you can see from 5 to 6 to 49 how this is important in terms of being able to sort, straighten, standardize. Okay? So now you know what 5S is. Now the fifth S is sustain. And what that really means is that clean factory we saw. The fact is that at the end of the day, you want to be able to put the tools back in the rack where you found them, so that you know exactly tomorrow morning when we start exactly where they are. We want to continue to have a clean factory so that if we drop a chip or something like that, we're not ruining anything. So it's tough. You know, this is like clean your bedroom. Yes, mother, right? I've cleaned it. I want it clean next week too, right? Keep it clean, and we're gonna. As they say here, it's hard to achieve. I used to do a walkthrough and created the Golden Broom Award, the Golden Broom, and we literally had a hardware store broom that we sprayed with gold paint, and we'd walk the factory to make sure that, you know, the folks that had the cleanest shop, the sheet metal shop, the machine shop, you know, we wanted to keep it clean. Aerospace has, you know, is the largest exporter in the United States. When we talk about the balance of payments, the aerospace industry always leads in terms of number of exports. It's a flagship industry. Obviously, you know, today everything is air shipped. You know, you've got FedEx and UPS has a very large fleet. It's not just brown trucks. They've got a large number of cargo travelers. But we get products, used to be only high-value products. Now we get a lot of things. Sushi is flown in daily. Fresh, iced tuna flown in from Taiwan every day. It's hard to believe. Flies right into San Francisco. So we move people and goods, you know, with our global positioning system and so forth. And our satellites, we've got wonderful information now that we never had, you know, from our satellites. Obviously, national security and the concept of, you know, hopefully going back to the moon and Mars, and, you know, the innovation that the technology provides is made aerospace an exciting place to work. But some terrific work that was done here at MIT in terms of studying the evolution of products and innovation. This is in green color, I guess that's sort of green, the number of major typewriter companies in the world. And you can see it goes up and down like that. And at the peak, there were like 75 companies making typewriters. Now, my mother was a secretary, and she used to, her favorite typewriter was a Smith Corona. Well, Smith was a typewriter company and Corona was a typewriter company, and they merged and they made good typewriters. Ultimately, Remington made typewriters, and then IBM made typewriters. And when I was a young engineer, and some of you may have seen these, but you can't even find them anymore, keys that went like this, the little ball would just flip to the right position and type, and the really good typists could type much faster on those things. And it was a status symbol for the secretaries if you could get an IBM Selectric typewriter. But what happened is that the advent of the computer later on, I mean, you can't even find typewriters today. I mean, you know, they're in museums. What the research has indicated is that when an invention happened, a whole bunch of people jump into the industry, and then as the product stabilizes, where innovation, they've gotten about all the gadgets into it that make it better, the process, not the product innovation, but the process innovation, who can make the typewriter more efficiently and deliver it to the customer at lower cost, and there's some consolidation. Smith and Corona get together and become one company, and they, in fact, the numbers of companies reduce. Automobile industry, I mean, and Earl and all that, we can remember Hudson Automobiles when we were kids, Hudson Automobiles and Studebaker and Nash. Folks probably have never, you might have heard of them, but these companies, the Studebaker company, started in the world in making Conestoga wagons to go out west, and then they wound up making early automobiles. And in the late 40s, after World War II, they had a very unique company. The automobile industry has gone down from cars, enclosed steel body cars. Look at all this. There were, a whole bunch of companies in that industry, and now we have 3 in the United States. And then, a couple of years ago, Chrysler was not really a U.S. company. It was, Daimler-Benz. So the same product phenomenon happened in automobiles. And here we are here. There's a chart that I sent Annalisa the other day. We had 54 aerospace companies, and in like 1940, and that has consolidated down to where you've got, in the commercial airplanes, you got Boeing and Airbus, then you got some big Embraer and Cessna and so forth, the folks that make business jets. But the number of companies is really dramatically reduced. And the same phenomenon would have been predicted down here, except during the Cold War, it was important to keep companies alive and keep in what we call a warm base or a hot base in order to be able to produce them. But the question is, as happened here and here, as the efficiency improved, only those companies that had a better business model really stayed in the business. And so the question is, are we in trouble in aerospace? We hope not. But the point is, the very fact that we're doing Lean Six Sigma, and transforming ourselves into very, very efficient companies, hopefully that will in fact sustain the industry. So that's something to keep in mind, because we used to say in Pentagon budgeting that only only the healthy tigers survive, the weak ones get eliminated, and so the name of the game is to keep going. So the question is, the industry that came of age in a cold water cannot survive with an obsolete business strategy. And so we're going to talk about that strategy. Now, for many, many years, starting with World War II, the name of the game was high priority, develop the aircraft. This is even pre-missiles. And the way we got the price was, what was the cost? The government would audit the cost, and then you'd put 10 or 15% profit on top of that. And that determined what the price was. Over the last 10 or 15 years, the customer has gotten a lot smarter and has said, look, this is what we're willing to pay, and this is what we think is reasonable profit, same as this, 10 or 15%. And if we're going to buy it from you, you better get your cost down. Otherwise, A, you don't get the business, or B, you don't make any money. So the customer determines the price, and we in industry have to lower the cost to achieve the profit. So when we go through a design process, our design has to come up with the fact is that we've got to meet the range. You guys are aero engineers. Range and payload and reliability and maintainability and so forth, all of those specs. But one of the key specifications, we're going to talk more about this when we talk about cost, one of the key specifications now is achieving the cost. So we talk about design to cost, design to cost. And we keep iterating the design until we achieve that cost. And those companies that don't iterate the design to achieve the cost at the beginning wind up not making money, So, big issue. So, we use Lean to help us achieve and to make sure that we're efficient in all of our processes. So here's some basic data. Now this is the return on invested capital, and here, this is the average of the capital goods companies. These are the big companies in the United States that manufacture. These are not service industries. These are big capital, make big equipment. And you can see that basically almost 8% margin, net margin. And you can see over here that the return on the invested capital is, like 11 or 12%. And you hear some of the aerospace companies. In fact, it's interesting, as we've taught this course, how many of these companies were down here. Boeing and Lockheed and so forth, we were all down here about 5 years ago. And we've, in fact, become more efficient. Now, this is 2007. So actually, it's funny to watch those things. We're becoming more and more. And Rockwell used to be down here, and they've gone way up here. And Clay Jones is the CEO. I met him back in like 2002, and he came to see McDonnell Douglas, and because we were doing lean, and he wanted to learn how to do it, and he went back, and now they have lean electronics, and they've done very, very well. Done very well. So the point of the story is that the aerospace industry has been moving up into what we call the green zone. So we have red, yellow, green, and a lot of the military charts and a lot of industry charts now as a way of communicating red, yellow, green, just like a stoplight chart. Not so hot, caution. It's become lean, is moving in that direction, and it's a gratifying phenomenon. We typically have underperformed capital goods manufacturers, but lean is driving us to the right-hand corner, which is great. We're talking about enterprises, and that's a key word in lean. And there's lots of different kinds of enterprises. Programs, Joint Strike Fighter, the Boeing 787, Dreamliner, Global Positioning System. Then you have a multi-program enterprise. For example, Raytheon. I have Raytheon Marine Electronics on my big sailboat, and we'll show you that later on. The United Technologies is Sikorsky, Pratt & Whitney, Carrier, air conditioning, the Otis Elevator Company, lots of products, lots of programs. And then we've got the national and international enterprises, the aerospace enterprise, our whole aerospace industry, military and commercial. The European, Airbus and the other companies, EADS. So we can have enterprises that are overlap each other, intersect, and we'll show you how they can in fact be connected. So what is an enterprise? And it says one or more organizations will have related activities, a unified operation, and a common business purpose. So here we are here with the end user, and lean, we focus on the end user. And remember, just a new concept of, is the end user the airline that buys a 787, or is it the pilot and the maintenance mechanic? Because those are the real end users, and we want to make it easier for the pilots and easier for the maintainers. And then engineering's job is to conceive a product design that achieves the value that we want to deliver to the end user. And then manufacturing operations and our supplier network add the value to create the product. And there's a bunch of supporting organizations, finance that keeps the books, the human resources people that acquire the personnel and provide the benefits and so forth, and do the training, legal obviously, and then product support. In a military environment, roughly, 1/3 of the total life cycle cost is the acquisition. How much do we pay for the development and the production? But 2/3 are the operations and support costs. And it turns out that if you put the product out in the field, and we've got a good customer here, the maintenance cost, the training cost, think about training pilots. 50 years ago, it cost $100,000 to train a pilot. Today, it's in the millions. But the amount of money for spare parts and repair and overhaul, so 2/3 of the life cycle costs are in the product support area. So all of these are part of an enterprise, and you can see the intersections of the product development guys send specs to the suppliers to build the parts. They also send specs down to manufacturing with the blueprints to do it and so forth. So you can see those intersections there. So if you basically have a headquarters This could be the headquarters of what used to be McDonnell Douglas in St. Louis, and then you've got a factory there, and it turns out that we, in fact, have suppliers, and we, in fact, go out to our second and third tier suppliers. What's a second and third tier supplier? We buy titanium from outfits like RMI. We're buying titanium from Russia today. They have a huge source of titanium. We get Alcoa, obviously aluminum, and so those are first tier suppliers. But we also then go down below that to our machine shops. That Hicksville Machine Shop on Long Island makes big machine parts for us, and we have to make sure that that whole supply chain is in fact synchronized and working. Boeing is having trouble right now on the 787 because of the fact that the supply chain was a major, it was a major new innovation, the way they were going to, in fact, build this airplane, because they gave design responsibility to major subcontractors who flowed that down to sub-levels, and some of those parts didn't flow up on the same very, very aggressive schedule that that they put in place for the 787. So supply chain is a key part of it, and they're all part of the lean enterprise. So here's a multi-program business unit. You've got the end user, okay? Let's say that an airline, but the end user is like a pilot and a mechanic. And you've got employees on the F-18. Boeing was the prime. Northrop Grumman made the aft section on the Joint Strike Fighter, the F-35. Lockheed is prime. Northrop Grumman is making the aft section. British Aerospace is making the forward cockpit. So those are partners. You've got detail suppliers that make actuators and that make alternators and that kind of stuff. You've got the unions, the IAM, which is the machinist union in St. Louis, the United Autospace Workers in Boeing, Philadelphia. Society and Congress are stakeholders in this thing, because the fact is that Congress is paying for it, and society is depending on these products, for transportation and for defense and so forth. Corporate leadership, shareholders. So all of these are stakeholders because they've got a piece of the action. If we shut down a plant, we shut down a plant in Columbus, Ohio, and there's a whole bunch of people that aren't working there anymore. And there's a responsibility to the shareholders to get value, but on the other hand, part of the stakeholders in terms of society is, for example, the communities that we serve. And so all corporations today, most of the big corporations, try to be good community neighbors, and in fact try to do things that don't hurt. But I mean, I was on a consulting contract last February in Detroit when Ford said they're going to cut 30,000 people. Whoa, boy, talk about sad people. So here are what we're trying to do is have value for all of the stakeholders. Obviously, the value, we want the best value delivered to the customer. We've promised performance, we've promised price, we've promised reliability. To the end users, our employees, we're saying to you, make good products, we'll sell a lot, you'll have jobs, for your families. The unions, it's the same situation. The shareholders, return on investment, you buy a share of stock and you want to get dividends and you want to see the stock price go up. The partners, Northrop Grumman and Lockheed, working together. The suppliers, and this is Eaton that makes electrical stuff, and it's Parker Battea that makes actuators, and Honeywell that does flight controls, and then society, we're trying to, in fact, have the benefits of being able to fly and, go see your grandkids kind of thing. So what is a lean enterprise? And good definition, and in fact, he just came back in the room, but Professor Merman pulled together a bunch of professors here from MIT about 5 or 6 years ago and wrote this book, The Lean Enterprise Value, Insights from MIT's Lean Aerospace Initiative. And it says a lean enterprise is an integrated entity that efficiently creates value for the multiple stakeholders by employing lean principles and practices. And you remember, these are all of the elements that it takes to create an enterprise. And what we're trying to do is to create value, for all people in the total supply chain and in the enterprise. Let me take it the other way around. We have an Army officer here. The Air Force spent 20 years developing the F-22. It was called the Advanced Tactical Fighter. The Air Force wanted that for $35 million a piece. Took 20 years to develop, and you can add inflation on that and, whatever. But the point is, today's F-22 costs like $180 million. $180 million. The Air Force wanted to buy 750 of them. 750 of them. And what happened is that Congress said, we can't afford a $180 million aircraft and buy 750 of them. And what happened is, over time, now the Air Force can only buy 183. 183, and they wanted 750. Now there's a lot of pressure right now to try to keep the line going, and whether that happens or not, but the chances are we'll never get to what the customer wanted. And the issue here was the fact is that the value that the customer wanted, the end customer, was not delivered, because from a strategic and tactical standpoint, having greater numbers gives you an advantage. Problem is, we're not going to be able to get that advantage because we're buying less. So delivering value is a big deal. My favorite example, and I'll probably talk about it tomorrow, is that if I told you that I have a wonderful Ford Focus outside on the curb, and if you sign right here, it only costs you $60,000 for the Ford Focus, and you say, Al, I don't think I want that, right? The point is that intuitively, we know what value is, and $60,000 for a Ford Focus doesn't intuitively compute. And so the name of the game is the market people tell us what is it that the customers want, and it could be a Mach 1.6, $35 million Joint Strike Fighter kind of a thing, or it can be a $220 million large 747, or it can be a laptop computer for $900. But we all know intuitively what the features and the attributes that we're looking for and what we sort of want to pay. And if in fact we can conceive the design and iterate the design and get the waste out of it so that we can deliver that value to the customer, we'll be able to sell them, and the enterprise will thrive, and all those stakeholders have a piece of the action, and we've got happy employees and happy communities and happy shareholders. So we talked about business acquisition, market research, engineering defining the requirements, iterating the product design and coming up with robust processes to make repeatably to get the variation out of them, high quality, managing the supply chain down through the second and third tiers and further, efficiently producing these, and then obviously we have to deliver them to the customers and then support them for the life cycle. And so those are those big life cycle processes, but then there's a bunch of supporting infrastructure, finance, information technology, human resources, and so forth, and Lean applies to these too. Every one of these processes can be more efficient. I used to do Lean lectures at Boeing, and in addition to my job as Vice President of Engineering, and I had a contracts administration person who was actually a lawyer, and all of a sudden he says, Al, I got it, I can see why we want to be able to get on contract sooner, because we have a whole bunch of people, trying to wait for the contract go-ahead, and these guys are still fooling around trying to get the terms and conditions, and so they were trying to get the contracts administration folks even leaner. So that's the book, and I heartily recommend that you get it. Jim Womack and Dan Jones and Dan Roos, and the story of lean production, how Japan's secret weapon in the global auto wars will revolutionize Western industry. And it has spread from the automobile industry in Japan to the aerospace industry, and now hopefully Detroit's going to get the message. But a 3-star general in the Air Force said, can the concepts and principles and practice of the Toyota production system be applied to the military aircraft industry. And they gave a contract, a study contract, to MIT, and in the early 90s, the answer was a resounding yes. And if we focus lean on enterprise valuation and creation, and Professor Merman, for more than 10 years, led this whole effort and was very, very successful in developing a body of knowledge that really works. All the major aerospace companies are using it. It does produce value. In fact, now it's trying to spread it to the healthcare industry and other organizations. And but lean does pay off. And in fact, the Air Force said, you've got this great body of knowledge, and we now know that it does work. How do we spread that and diffuse it so that it's being taught in colleges? And the Lean Academy, of which this is a piece, was created about 5 years ago to disseminate this whole body of knowledge by conducting courses like you're in right now. So here's some examples. This was General Dynamics and then Lockheed on the Atlas program. You can actually see that on the initial development, it used to take 48.5 months, and they actually got it down to 36 months and down 27 months, ultimately got it down to like 18 months, going through a series of major changes and going through the lean processes to in fact achieve what they want. The F-18 Super Hornet, huge change in requirements, more payload, 3 times greater ordnance bringback when they land on the carriers, 40% increase in unrefueled range, 5 times more survivable, designed for growth, big change in reduced support costs. And they did it within budget, did it on schedule, actually ahead of schedule, 1,000 pounds underweight, and there's a high correlation between those program management practices and our lean enterprise. And that's all the way from trying to do all of these various missions, as you can see here. It's one of the big success stories of industry. And Rockwell Electronics, we mentioned Clay Jones before, 25% improvement in productivity, 46% reduction in inventory, cycle time reduction, big deal, 75%. And you know, it also works in the office on technical manuals, on paper processing, accounting, publishing cycle time, 72% reduction, work in process reduction, 70%, 38% productivity improvement. So it does apply everywhere, and we're going to give you some exercises that talk about it. Kanban is a Japanese word, and it's a lean tool that we use a lot. We use it in the office in terms of processing engineering drawings, and we use it out in the factory. And there's several ways of making it apply to the movement of material and parts in the factory, or information like in drawings and parts cards and so forth. And sometimes it's actually done with a card. And we're going to go through some Kanban exercises here, but basically what it says is that, remember I told you originally if we were going to build 12 Apaches that I'd put 14 parts out there, and you'd give all 14 forgings to a machinist and say, here's a job card, go do it. Now we give him one, and we in fact, when he finishes machining that, he looks over here and there's a card that says he can go get his next piece, and then he puts a card in, and we move it. We do single piece flow. Because if he makes a mistake on 12 forgings and machining them, we've got 12 rework parts or 12 scrap parts. So empty part, one way of doing it is an empty parts bin. So in fact, he sees an empty one, the parts guy fills it up, an open space on the production floor. We paint yellow boxes on the floor. And so if the part is there, I grab that part. When it's empty, the production control guy says, whoop, give him another part. So that's another way of doing it. It reduces inventory, it reduces scrap and rework. And we do the same thing with engineering. You can have racks on the wall for them to do that. So it took 30 years for Toyota to develop all aspects of this system. And you can see that they did their early experiments with Kanban in the 50s. Took them 10 years and they put it company-wide. And then they they drove it all the way down to their first and second, third tier suppliers, and they're continuing to develop what we call the Toyota production system. Boeing now, for example, calls that the BPS, the Boeing production system, which is basically the Toyota production system, and they're very, very proud of that. So how long do you think it might take a large aerospace company to implement lean thinking across their enterprise, starting with the knowledge now available? So in your folders, you got some cards, colored cards. I think they're okay. How long do you think it would take? There's a blue card for 20 years, a red card for 10, green for 5, and yellow. How long do you think it would take a large aerospace company to implement lean across their enterprise? Just hold up the card. Blue card? Okay, you can hold them up. Well, I see a bunch of red cards. Yeah, red and blue. You're right. It takes a long time. It takes I mentioned to you that I was, in addition to being Vice President of Engineering, I was the head of lean for Boeing Integrated Defense Systems. And when you think about the Apache and the C-17 and the F-15 and the F-18 and the Chinook and the Apache, and I had all of those, it takes a long time to get all the organizations up to speed and to drive all these principles down. And it's just it's a lot of work, and it's a continuous journey. So welcome. You've taken step 1, and the takeaways on this is that Six Sigma started with the Japanese automobile industry, and then the electronics industries, and now into the aerospace industries. And I mentioned to you now that the hospitals and the healthcare people are interested in. And if you watch next time you go to the hospital, or your mom and dad go to the hospital and all that, and you see the bill for an operation or something like that, you know how very, very expensive it is. My daughter, and Medicare paid for that, and because she was having trouble walking. But I mean, $70,000 is a lifetime of trying to. But our medical business could stand some lean thinking. An enterprise is a core, okay, and extended boundary, and the extended boundary, the employees and the suppliers and the communities and the stockholders, and certainly, today is step 1 of learning this, and you can continue to bring it back and keep thinking about it in almost anything you do. So, just on a card, on one of those white cards, just write down, for example, for your particular department. I guess we're a little late here, but anyway, write down just quickly who are the stakeholders. If you've had an internship in industry, just write down. You don't have to put your name on it. Write down who the stakeholders were for that function. If you were in engineering design, who was the stakeholders? Put it down, okay?